Hello and welcome to Color Multimedia Enterprises. My name is Luke, also known as TNRA, and in this tutorial we are going to take a look at player coordinates, so being able to allow the player to be set to any given coordinate at only ever one given time, if that actually makes any sense whatsoever. And we are also going to adjust a few things with the camera so that we can actually get the camera moving instead of the map moving. So without further ado, let's get started. Hello, so as mentioned in the introductory video, what we will be taking a look at in this tutorial is the ability to implement this coordinate system that I was talking about, and being able to, of course, change a few things around a bit. So first of all, before we go on to actually moving into actually implementing the tile system, or coordinate system even, the first thing that I would like to do is just remove this map move thing here and actually do something a little different. So we're actually going to move the camera instead. So it's not going to take too long. And the reason why we would want to do that is because we want to be able to still do operations on the X and Y of the player without affecting the way in which the map is rendered, if that makes sense. That'll make sense at some point. So the way in which we will be modifying and moving the camera is by taking the position of the player for when we first draw it onto the screen, and be able to take the relative position and then move the camera based on the relative position of the player, because obviously we want the player to remain within the center of the screen, right? So in order to do that, what I'm going to do is add two new variables. So I'm going to say relative player X, which is going to be a float, and profile relative player Y, which of course is going to be a float. And down here, once we've created the player and we've done all this player drawing and stuff like that, because now that we have passed in these, we will be able to know where the X and Y positions are. So now what I'm going to do is I'm going to say relative player X is going to now be equal to player.x, well, player.anim.x, and relative player Y is going to be equal to player.anim.y. So now when we go down here, when we have this camera move operation, what we're now going to do is we're going to say, okay, I want to flip the relative player X and add that onto player.anim.x. Now what we also want to do is, because when we resize the game screen, if we were to just operate it like that, what will end up happening is that the player animation is going to move faster than the camera is going to move. So we actually need to multiply this value here, the result of that, by the ratio at which the camera is currently at, if that makes sense. Probably doesn't, but so I'm just going to say here, I'm going to obviously do the relative player Y. I'll tell you what I mean in a moment. So I'm going to say player.anim.y. So what I'm now going to do is I'm going to go into my core, and I'm going to open camera. I don't even know if I'm spelling it correctly, it's so small on the screen. So if we go back to here, as you can see, we've got our move, which is going to be X and Y, and when we resize the camera, we've got these values, scale X, scale Y. Now what we want to do is we want to actually store these values elsewhere as well. We don't just want to scale the current screen, we also want to store what those scales are somewhere else. So what I'm going to do is I'm going to put in two public vars here, and I'm going to call it current ratio width and current ratio height. So current ratio height, type, god damn it. There we go. Okay, so now what we want to do is we want to take those values, right, and we want to just set those as well. So I'm just going to go down here and set those like that. There we go. And when we go over here, let me just double check, we want to actually modify this so that the scroll rect remains the same when we resize the window, because obviously if we were to move it and we just did it by render width and render height, the actual render, it's actually going to reset to those width and height, so we need to multiply the current ratio width and current ratio height by those as well. So I want to make sure that that happens. So just copy those, paste those in there. Alright, so let's quickly save that. So now when we go back here, what I'll now do is I'll say multiplied by the camera dot current ratio width, and so that you can see what's going on, I'll just do that. And this is going to be multiplied by camera dot current ratio height, like that. So now what I'm going to do is I'm going to go into the folder. It should be, no, not that one, somewhere. Why can it not be in my recent? Let's take a look. Desktop. This is on the other screen, which is why you can't see it. Okay, so RPGFL, command prompt, and again I need to keep on dragging things over. So hxlib run OpenFL, so we're going to just test this to see if everything is correct. And I forgot to put in the build bit here. Build. There we go. So let's just make sure everything's fine and test it. Right, so that compiled correctly, so we're just going to go into Nuco and make sure that everything's running as expected. Oh, got an error, unfortunately. It's recording on the other screen, which is bloody annoying. Hang on. How to best do this? I really wish you stopped doing that. No, they need to resolve this Nico issue. Every time you open, it'll come up with an error and then it'll just instantly go away again. It's bloody annoying. God. What is the error? That's what I want to know. Stop doing that. No, that was too slow. I can barely see it. Invalid operation X? Did I do something wrong? Valid operation X. What did I do? What did I do? Hmm. Camera? I can't think of what the problem would be. Huh. Ah, dear. Right, let's go back to our folder again, try it again. Need to know what the source of the problem is. Does it just say line 43 on some? Finally, okay. Line 83, invalid operation times. Wait, what? Why is that an invalid operation? Camera move. So we're inverting the relative player x, we're adding it to player.inm.x, and then we're multiplying the result by the camera.current ratio width. What's the problem with that? Well, there was no problem before. Looks I really don't know what's going on, if I may be honest. It's complaining at me and I don't like it. Those are floats, those are floats, those are floats. Relative player X, that is a float, yeah. Okay, I know that's a float. Current ratio width, did I make that a float? Pretty sure I did. Current ratio width, yeah, it's a float. What the hell are you complaining about? Oh, of course. The joys of programming. Because we're in Nico, we need to set the default values, and that needs to be 1. Current ratio height is equal to 1. There we go. Okay, I think we get there in the end. Right, so let's save that and rebuild. This should now actually work. Just missing completely simple things, and I really don't like doing that. You're in time. There we go. Okay. Yeah, I'm still recording. Alright, so let's take a look and see the results. So it should be fine now. Alright, so here we are in the world, and we're unable to move because I decided to mess things up somehow. Interesting. I think there's a few things that I do need to adjust in our player class. So let's open that in a new tab. So let's go over to our player class. Yeah, we're not actually moving the player. So we need to redo that. So we're just going to say anim.x plus equals delta time times speed, because we know we've got that speed variable there, and that actually needs to be y minus equals, because we're going up. And if we're going down, it needs to be plus. If we're going left, we are going to minus equals on the x-axis, and right, we are going to plus equals on the right on the x-axis. Okay, so let's take a look at that, and we should be all good for the camera bit, and then we can obviously move on to actually implementing our tile system and actually creating passable tiles, which we will be able to do for our collision detection. But for the time being, we'll just implement the tile system for the time being, so that's all fine. Let's just double check just to show you the results. So now that when I move, the camera is now moving accordingly. Obviously when we're moving around like this, it's not doing any collision detection or anything like that. So we're still moving over tiles, nothing exactly fancy going on here. So now what I'm going to do is I'm going to implement some things to the player which will allow us to grab the tiles based on our position of the player. So what I'm going to do is I'm going to create a few more variables before I decide to go ahead and do that. So I'm just going to say private var x is float, private var y is a float, and over in our new function, when we have initted our animation, I'm just going to say x is equal to, actually no, let's not do it there. When we draw it, we're going to say x is equal to, when I can finally type, x is equal to anim.x and y is equal to anim.y. So we're setting the x and y up here. So now what I'm going to do is I'm going to say where our tile for this player is. So on the map, so I'm going to say private var current tile x. Again, eventually when I can type, current tile x, which is going to be an int. I'm going to say public var current tile x, and this is actually going to be a property, so we're going to say get and null. So we're basically saying, okay, we want this property to be read only. We only want to be able to read it, and then I'm just going to say function get current tile x. So this get prefix is basically a way in which we can use the get accessor for this property here, and then execute whatever is required and return the value for this property. So all I'm going to do is actually do a return. So I'm just going to say return current tile x, and that's going to be equal to math.ceil. So we're going to ceil x divided by mapref dot cell width. Now we don't actually have a map reference, so what I'm going to do is up here I'm going to put in a map ref, which is actually going to be a public map ref, which is of course going to be a tile map. Now the way that we're going to get that map is we're going to do it through the draw function here. So I'm going to say map ref, which is going to be a tile map, right? And then I'm going to say this dot map ref is equal to map ref. So it's just basically a reference to the tile map that this player is going to be on. So now that I've got one of these properties available, I'm just going to copy and paste that and make the appropriate changes. So I'm just going to say Y there, Y there. Again, I can type. There we go. Y, Y like that. And here I'm actually going to say we need to put this in brackets because otherwise that needs to be -4 like that. Actually, no, let's make it -5 to give us a little bit of leeway. So this Y -5, the reason why we put this into brackets is because if you've been to, if you've done basic arithmetic, division would otherwise go first. We want to make sure that the Y -5 is done first, and then we actually do the check for whether or not this player is in Y3 on the map or something like that. Okay. So now what I want to do is I want to be able to take this map reference and do the logic first before we actually position the animation correctly, so that we can actually do the collision detection eventually. So I'm going to say Y is equal to, or minus equals rather, delta time times speed. And then I'm just going to say anim.y is equal to y, right? And then we're going to do the same for these. So I'm just going to cut this and y like that. That is then going to equal y. So that we're not really changing much apart from the fact that we actually now have a way in which we can tell whether or not this player is going to be in a given tile. So we'll do a test on that in a moment. Let's just quickly do this because we're basically preparing for the collisions themselves eventually. X is that, and then that's equal to X. Okay, so what I'm going to do is I'm going to trace, so every time we move we're going to trace to see where we are on the map. So the way I'm going to do that is I'm going to just call current tile X and current tile Y. And then when I open it in Nico, once I've saved and built, we will be able to see where we are on the map. So in order to do that, we seal X divided by map ref.cell width, because each tile is going to be dependent on this cell width. In order to know whether we're 3 tiles, 4 tiles in, we get that width and we divide it by the X position of where our player currently is. So we do that operation, we do the logical operation first before we actually update the animation and where that's positioned and rendered. So let's now, did I save that? I'm not 100% sure. Let's do the check anyway. So now when we build it, actually, no, we forgot to actually do the pass into the reference. Obviously, as you can see, it's not doing it. So if we go back to our main class over here where we did the player.draw, we're now going to put in map here like that. Now we're done. So let's go back to our command prompt, let's build that and see the results. Oh, tile map has no filled cell width. So we need to, shouldn't really be called offset, to be honest, because it's a bit, that doesn't really make sense. We want it to be cell width and cell height, so I'm just going to save that. I'm going to go over to our tile map, so open T src core tile map, and in here we would just want to change this to cell width and cell height. So I'm now just going to say offset X. I should have done this, to be honest, and we want to change it to cell width, so I'm just going to say and we want to place it again. Alright, and then same for offset Y. Yes, we want to match case. Cell height, like that. Okay, there we go. Alright then, so we'll save this and then we will rebuild. In your own time. Obviously, because I'm recording, it doesn't really help. So let's go back to our folder and let's see where we are on the map. So here's our game and here is the console. So as you can see, it's printing out 7.6. That's where we are on the map. So if we move, we can see if we go down here, we are at 7.0, and as soon as I move within the boundary of this tile here, we are in 7.1, 7.2, 7.3, 6. As you can see, it's constantly printing it out because obviously it's on enter frame. So yeah, we've got our basic tile system, and that will allow us to go on to doing collision detection. So thank you very much for watching. I hope you enjoyed. In the next tutorial, of course, we will be doing tile collision, and we will be taking a look at some other things as well, because there's quite a lot going on in the next tutorial, so that's probably going to take a while. Just so that you are also aware, I now have Patreon. The link is in the description below the video, so if you enjoy these tutorials and you wish to help support me and help to allow me to get by in life, because unfortunately I have no job, at least until I eventually find one. But until that time, I do have Patreon, and that is available for you in the description below the video for any of you who wish to support me. So thank you very much for watching once again, and I will see you next time.